So we're here at Microdul, and who are you?
Well, my name's Phil Pull. I'm Director of Semiconductors at Microdul. And Microdul is a company based in Switzerland, in Zurich. And we have 3 business lines, one doing micro modules. We do implants, for example, that get implanted into humans. And in the cochlear area, for example.
In which area?
In the cochlear area. Well, in hearing, I can't say more than that.
Yeah.
We have industrial applications, and we have 3 product groups, as I said. One is modules, and I lead the semiconductors. In the semiconductors area, we offer low power mixed signal analog circuits. So it's ideal for this kind of occasion where you have energy harvesting and wearables. We come from the switch watch industry in my area, so we're used to designing circuits in the nanoampere range.
Are you a Swatch group?
No, we're not with Swatch Group, we're independent. So the Swatch Group is quite a big company in Switzerland, and we're independent. Our origins are with Philips Semiconductors. We're a management buyout from Philips Semiconductors.
But so the technology used to go, and it goes in a bunch of watches?
Yes, we do watch chips, and we do chips for sensors as well.
And the Swiss industry has to adapt, has to do some crazy stuff with the wearable, with electronics, right?
Exactly, and we're already in contact with people like the Smart Watch Group, with Pascal Koenig, and other companies to which we supply watch chips. Of course, the Swiss watch industry is based on a fashion statement as well for the quartz watches that you can easily adapt there for that particular industry.
So what kind of functionality would you add to the watch?
That's a good question. Everyone is looking for the killer app for watches. Everybody. And how that will be driven, nobody has the answer to. So I don't have an answer to that. We basically provide, our intention is to provide a watch chip that can serve as a building block in such smart systems. And to do that, of course, you need to have connectivity. So that's the area where we're working as well.
Connectivity. And before you were mentioning something about ears. Are you enabling people who couldn't hear to hear? Stuff like that?
We don't do that ourselves directly. Our customers do that, and we manufacture for them modules that are then implanted into humans and indeed enable people who can't hear to hear again, yes.
So around here you're showing a bunch of what are you showing around here?
Well, here you can see this is for Carver, I'm allowed to say that. This is their Touch Go application where the circuit, we made it, and it's couples into the human body field, implants a signature, and that means you have a card on you. It could also be built into a smartphone, for example, and the door knows to let you go through.
So something is implanted?
No,
it's just a card?
This is just a card in this case.
All right.
Yeah.
So is it some kind of RFID? How does it work?
This is just basically every human has a field, an electrostatic field. This field is surrounding your body. And if you're a healthy person, this field also extends a little bit apart from your body. And if you can put a signature on that field, then objects know who you are. Yeah, and you can put this signature on via a capacitive coupling.
A capacitive coupling?
Yes.
So how much power do you need to put the signature?
Nothing. In this particular case, the signal is so small that it's below the noise level. So it's no impact on health or anything like this.
No impact on health?
No.
But how long is the battery life?
For this particular case, it's about a year or so.
A year? You just have this in a pocket or where?
Yeah.
And then you just open the door by touching the handle?
Yes.
It works?
Yes.
Does it work?
Yes.
Who's using it? Swiss banks or?
No, it's not. It's actually made for semi-public buildings, so hospitals, old people's homes.
Is it mass production?
Yes. Carver in Switzerland making it. We make the chip for Carver, and Carver make the product.
But this can go to many different applications, right? This could go to...
Yes.
Everybody should have this, no?
Yes.
Somehow.
Yeah.
But how big is it going to be?
I don't know. We are a service provider and a product provider. That means our customers are the ones who bring the stuff in the market. So that you would have to ask them for.
And you have a list of customers, but you cannot say who it is, right?
Unfortunately, no, because a lot of the customers, particularly in the medical area, they're very, very strict on the confidentiality. And that's one thing, being a Swiss company, you can trust us to keep things confidential. Yeah.
Nice.
In the case of Carver, we're allowed to say that. They don't mind us saying it. But for other companies, it's not.
So your customers just have numbers. They don't have names, right? I'm just joking.
Yeah.
Okay. And how about here? What is that stuff?
Well, here we see an example of chip in tape. This is just showing a delivery form.
A chip and tape.
Chip in tape. So the chips are actually in this tape here. This is a conventional industry thing.
Can you hold this up?
This is an example of chip in tray, which we can deliver.
So what does it mean, chip and tray?
This is the tray here, and some people with small quantities, they like to have the chip in the tray so that you can pick it out and then put it into your application.
So what is in that chip?
Actually, this chip looks to me like a MD500, is it? Do you know what application this is? I don't know exactly what's in this chip, but it's one of our arrays, and we have got a certain function that has been put into this chip.
All right.
Yeah, and this is an example of a very small packaging form. It's called wafer level CSP.
Okay.
So chip scale package, and we have made this in 2003. We were one of the first people to make one of the smallest CSPs in the world. Came from Microdul actually at that time.
What is this CSP?
Chip scale package is a package that's the same size as the chip itself. So there are little bumps on here of solder, and you can handle this like a surface mount component. And it will be soldered onto the PCB board just like a normal surface mount component. The advantage, as you can see, is they're very, very small.
So you just pick one of them and put them on the PCB?
Yes, and then it's soldered.
That's it?
And then you have to put it through reflow to solder it, yeah.
How's the yield? All of them are good?
No, of course not. But the yield on this is probably over 95%.
So how do you test which ones work and stuff?
Oh, it's normal industry standard. You just have a prober. It's called a prober. This is a device which has needles coming down in a controlled environment which tests each chip.
Where do you fab this?
Well, the testing is done at Microdul itself, the wafer test, and the fabs are the standard fabs like TSMC, for example.
All right.
Yeah.
And what is this? What are we looking
There
here?
is an ultraviolet hardening light, so LEDs, used in a dental application, which we were asked to make special module where we make the module.
So what do you think about the IDTechEx show? What do you think about this print electronics and all that stuff?
I like IDTechEx because it brings all the emerging technologies together, and a lot of people with different opinions about how emerging technologies will evolve over time. So I think that's the advantage of IDTechEx, and it's short and it's very intensive. So everyone goes to the lectures, after the lectures everybody comes to the trade show, and then everybody goes to the lectures again, and then everybody comes to the trade show. So it's not like a normal trade show where you're standing up all the time. You have an element where you learn something, you can see something, and then people come to you. So that's actually quite a nice mix.